So we talked about finding equilibrium values. We looked at that example, and then we kind of tried to tie it back to this direction field idea that has hopefully become kind of familiar to us. And then the last thing we're going to do is talk about classifying equilibrium values. So we can find an equilibrium value, and we know it's somewhere that a differential equation will stay if you put it there. But what we're going to further do is talk about whether or not you are going to head towards that equilibrium value or not. So when we have dy dx equal to f of y, we can classify y star, an equilibrium value, by examining the sign of f of y above and below the equilibrium value y star to see if you tend to move towards that equilibrium value. This tells us if you move towards or away from. I'm not going to write the equilibrium value again. I'm just going to say y star. And then once we've done this, we visualize it using a phase portrait. So we'll talk in a second about how to build a phase portrait, but I'm going to go back to this example again to kind of show how it's related to something we've already done. So when we looked at this direction field, we said our equilibrium value was at k and 0. Oh, I should use stars because that's the notation we use. So our equilibrium values were at 0 and k. And when we make the direction field, we say, oh, things are negative here, or positive here, and negative here. You know, negative slopes, positive slopes, negative slopes. And then I just drew arrows that say like positive means up, negative means down, negative means down. And so when we make our phase portraits, we'll be able to see this thing that I've just drawn without drawing the rest of the direction field, but it tells us the same information, that you tend to head towards this value at k and away from this value at 0. And we saw that when we drew our little trajectories. If you start here close to 0, you head away from it, you head away from it. If you start here close to k, you head towards it, and you head towards it. So let's talk in detail about how we're going to do this. This is going to be kind of like the step-by-step guide, so maybe make a note next to this. So first of all, we're going to find y star for dy dx equal to f of y. So we're going to find y star, so f of y star is equal to 0. And then we're going to put all y star in order on a line, like a number line. And then we're going to examine sign of f of y between all y star. We're going to draw arrows up if positive, or down if negative. And then we're going to classify as one of 3 different things. we're going to say that they can be unstable, stable. It's going to be actually asymptotically, but that's not an important word that I need you to remember. Just you can know that that's what it is, or semi-stable. So unstable is going to be if nearest arrows point away. Stable is going to be if nearest arrows point towards. These are all in terms of y star. We're classifying the points y star. Oops. There we go. And then semi-stable is going to be if nearest arrows point through. So both away and towards. And I'm going to draw here pictures of what I mean by that. And they will become more clear when we have done a couple of examples. But this will just be a good little reference for you. So nearest arrows point away is going to look like this. Your point y star is going to be in the middle. 2 arrows will point away from it. Pointing towards is going to look like this. Y star is in the middle, and then 2 arrows are pointing towards it. Through is going to look like this. Either 2 things pointing up, you head towards it from one direction but then away from the other, or 2 arrows pointing down. Same thing, but heading downwards. So I know that was a lot of me talking. I'm going to do an example next to kind of show what this means. So we're going to go back to our dn dt is equal to Rn times k minus n for Rk, both being positive numbers. And I'm going to recall that we already did the first step. 0 is equal to Rn star times k minus n star. And we found that the n star were 0 and k. That was step 1 right here. Find y star. Now we're going to put all those, quote, y star in order on a line. So I'll go ahead and do that right here. Here's my line. Here's 0. And since k is positive, I know that k is above 0. So you always want to orient so that positive numbers go up. Increasing, if that means more to you than positive. And then what I'm going to do is I'm going to look at the sign of f of y between all y. I'm at this step right here. And so between is going to be in 3 regions. It's going to be there, there, and there. So all of these are values of n. So if n is above k, I have k minus n is negative. So like k is 10, n is 15, minus 5. Rn is positive. So together those mean that f of n is a negative number. And so I said, oh, we'll draw the arrows next. So we're just going to examine what happens. I found negative numbers right there. If 0 is less than n is less than k, I'm going to have that k minus n is positive, but r times n is still positive. Together, that means that I have a positive times a positive. F of n will be positive. And then finally, if I have n is less than 0, I'm going to have k minus n is k plus some number, positive. R times n is negative, r times some negative number. And together, those things mean that f of n will be negative again. Okay, so I just did this step right here, examine the sign. And then now what I have to do is draw arrows down for every negative and up for every positive. So there's my negative, there's my positive, and then here's my negative. Really all the heavy lifting, I guess, is in step 3. Step 5, I classify. I see if arrows point away, towards, or through, according to these pictures right here. Oops. So here I am. If I'm looking at K, I'm looking at this. Both my arrows point towards K. So that means that K is stable. Here when I'm looking at 0, both my arrows point away, so 0 is unstable. So what I would say right here is that n star equal to 0 is unstable. N star equal to K is stable. And I've classified my equilibrium values. I'm going to take this video a little bit over. I'm so sorry. Just a quick note on what these classifications mean. So K is stable. That means things go here. Another word for this is attractor. And 0 is unstable. That means things avoid here. And another word for this is repeller. Those words may or may not be important to you. I don't care about them. I just want you to know them if they're useful to you. So our next video is going to be our wrap-up and your practice problem. I know this one was a little bit long, so go ahead, take a break, and come back whenever you're ready.